Hello. When you're multiplying rationals, you need to first factor each numerator and each denominator. Then you'll multiply the numerators together, you'll multiply the denominators together, and you'll simplify. I'll show you what I mean. In this case, I have 5y squared over 3. I have a 9x and I have a 10y. I'm going to look to see if I can factor the numerators of each fraction. So when I'm looking at 5y's, 5, if I'm doing the prime factorization, there isn't any number besides 1 and itself that 5 can be broken down into, so it's already factored. Y squared, when I factor it, is y times y. I'm going to factor 3. But I'm thinking about its prime factorization form. There's no other number that you can break 3 into besides 1 and 3, so it's already factored. I'm going to multiply it by 9. 9 can be factored. If I'm thinking about its prime factorization tree, 9 can be broken down into 3 times 3, but then 3 can't be broken down anymore, so it'll be 3 times 3 for 9, and then you have your x. Divided by 10 can be broken down. If I'm thinking about 10, 10 is 2 times 5. I can't break down 2 anymore. I can't break down 5 anymore. So it'll just be 2 times 5, and then there's a y there. So now that I've factored each numerator and each denominator, it's easy for me to just multiply the numerators, which means just put the numbers and, well, the factors right next to each other. When it's written like this, and you've multiplied the numerators, which means you're just putting everything in one fraction, you're multiplying the denominators, which means you're putting everything in one fraction. Now you can simplify. If you have the same factor in the numerator and denominator, it turns into a 1 because 3 divided by 3 is 1. 5 divided by 5 is 1. X divided by x is 1. Apples divided by apples, 1. So I have a y. That'll become a 1. Ooh, look, I have a 5 in the numerator and denominator, so those will become 1s. And when I look at what I have left, that means I've simplified all of the factors that are both in the numerators and denominators. I'm left with 3 times x times y over what seems to be just 2. And that's my answer. My answer is 3xy over 2. Here's another example. I have 2x squared y over 3z cubed multiplied by 12xz to the fourth 6 over 6y cubed. My steps will be the exact same. First, I'll try to factor the numerator and denominators in each of the fractions. 2 is already factored, it's just 2. X squared turns into an x times x. Y is y. 3 is already factored. Z cubed turns into 3z's. I'm going to multiply that by 12 can be broken down. So if I'm looking at 12, 12 is 3 times 4. 3 cannot be broken down anymore, but 4 can. 4 is 2 times 2. 2 can't be broken down. The other 2 can't be broken down. So if I was writing 12 in its prime factorization form, it would be 3 times 2 times 2. You just write down all of the numbers that couldn't be broken down anymore. And then you have an x, you have 4 z's, and you're going to divide that by 6 can be broken down. If I'm looking at 6, 6 can turn into 3 times 2. So it'll be 3 times 2, and then 1, 2, 3 y's. So now I'm going to multiply them, which means I'm just going to combine the numerators and I'm going to combine the denominators and put them into one fraction. So I have a 2, I have a 3, a 2, a 2. I have 3 x's, I have a y, I have 4 z's, in the denominator, I have 2 3's, a 2, 3 z's, 3 y's. Just double checking. I'm looking, it said x squared and an x, which means there's 3 x's altogether, a y, z to the 4th means there's 4 z's. I have 3 z's and 3 y's. Okay, so now I'm going to see what can be simplified. See what will turn into a 1. Ooh, here we go. Already, I have 3's in the numerator and denominator. I have a 2 in the numerator and denominator. I have another 2 in the numerator, but I don't have another 2 in the denominator to make into a 1, so I'm just going to leave it the way it is. Okay, I have, ooh, okay, here we go. It's going to look funky, but I have the y's that'll turn into a 1. I have those z's and those z's and those z's will turn into a 1. Do I have anything else? I don't think I do. Great, just double checking. Nope, I don't have anything else that's in the numerator and denominator, so I'm ready to write my answer. My answer is what I have left, 2 times 2 times x times x times x times a z divided by 3 times y times y. All right, and this is also another place where you can check to see if you have anything that is in the numerator and denominator. Once you get rid of all the extra messiness of crossing things out, you can look again in the clean version. And I'm definitely sure that I don't have anything else to cross off. So my answer would be 2 times 2, which is 4, x cubed times z over 3 y squared. That's my answer. All right, I'll have one more example if you need it. Here we go. Same steps. If you like, what you can do is you can pause the video and you can go ahead and try to do this one on your own and then just check back in and see how I did it. So first, I'm going to factor the numerators, factor the denominators. I'm going to multiply them, which means multiply the numerators, multiply the denominators. So I'll then have one fraction. I'm then going to see what turns into ones, what I can cross off. And then finally, I'll just write my answer. All right, so 4 can be broken down. 4 is 2 times 2. So when I'm rewriting it, it'll be 2 times 2 times x times y divided by 2 is already prime. So we'll have 2 and then we'll have 2 z's. We're going to multiply that by 6. When I'm thinking about 6, it's 3 times 2. And so that'll be 3 times 2 times x times z times z times z. Yes, divided by 20. When I'm thinking about 20, I can think of any two numbers. 10 and 2, I can do 4 and 5. It's whatever you like. I'm going to show you both just so you'll believe me. So if I do 10 times 2, then that'll break down 10 more to be 5 times 2. So 20 would be 5 times 2 times 2. I'm just going to show you the other way so I can prove to you that it doesn't matter which numbers you start off with. If I do 4 times 5, 4 breaks down to be 2 times 2, and 5 can't break down. And if you look in both cases, you still have the same 2 2's and a 5. 2 2's and a 5. So again, it doesn't matter how you start because you'll still end up with the same numbers. So for 20, I'll have 2 2's and a 5. Then I'll have y to the 4th, 1, 2, 3, 4. I'm going to multiply the fractions, which means put my numerators in one fraction and my denominators in one fraction. So I'm going to have 2 times 2 times 2. There's 3 2's. there's 1, 3, there's 3 x's, there's 1 y, and there are 3 z's. 1, 2, 3. I'm going to divide that by, I have 3 2's in my denominators. 1, 2, 3. A 5. I have 2 z's. 1, 2. I have 4 y's. 1, 2, 3, 4. And I'm ready to start crossing off. Now, if you are the type that you have messy handwriting, you'll be crossing off things you're not supposed to cross off and all sorts of stuff. To organize yourself better, what you can do is you can make sure that when you're writing your numerators and your denominators, however you write your numerator, whatever order you put your variables in, that's the order you'll put your variables in the denominator. So I have x's first, so then I will put x's first. I have y's next, so then I would have my y's, and then I'd have my z's. So if you are the type that needs to be organized, I'm not. I'm pretty good at keeping track with what I have. I would write my denominator with, I have no x's in my denominator, so I don't have to worry about that. But then for my y's, I have 4 y's. So 1, 2, 3, 4. I have 2 z's, so then I put my 2 z's at the back. So that way they line up a little better. So when you're at this step, when you're crossing things off, yes, you might have to go all the way over to cross it off, but they're still pretty much lined up. So when I'm looking at my 2's, I don't have another 3 in the denominator. I don't have a 5 in the numerator. I don't have any x's at all in my denominator, but I have a y. It doesn't matter which one you cross off. And then I have my z's. So I would end up with 3 times x times x times x times z over 5 times y times y times y. And there are no z's left in my denominator. So my final answer would be 3x cubed z over 5y cubed. And I'm getting these cubed because I have 3 x's, so that means that it's an x cubed. If I had 4 x's, it'll be an x to the 4th. But this is my answer right here.